So we all know AI can write a pretty good story, or even a poem. But how does it actually connect to your calendar? How does it search through your files? Today, we're going to pull back the curtain on the hidden engine that makes all of that possible, the Model Context Protocol.
Right, we see these AI models doing incredible, creative things all the time. But the real magic, the thing that makes them truly useful, is connecting them to your world, your data, your apps. Now, until recently, that meant every single app had to build its own custom, one-off bridge to every single tool. How do you possibly scale that without creating, just complete and utter chaos?
Well, the answer turned out to be pretty elegant. Instead of building thousands of tiny, rickety little bridges, the community decided to build one single superhighway. The goal was to create one standardized bridge to reality for every AI.
Okay, so let's get into what this thing actually is. At its heart, the Model Context Protocol, or MCP, is basically a common language. Think of it as a set of rules that lets any AI application talk to any external tool or database in a totally standardized way. No more custom jobs for everything.
And if you're a developer, you are probably nodding your head right now. This is a lot like the Language Server Protocol, which was a game changer because it saved everyone from writing 100 different extensions for 100 different code editors. MCP takes that exact same brilliant idea and applies it to the world of AI agents and their tools. It creates one standard to rule them all.
So, how does this all work? Well, it really boils down to three simple core ideas. First, you've got tools. These are the verbs, the actions an AI can perform, like send email or query database. Then you have resources. These are the nouns, the data it can actually access, like the content of a specific file. And finally, you've got prompts, which are kind of like recipes that tell the AI how to use a tool with a resource. For example, summarize this resource and then use the send email tool to send it to my boss. Simple, right?
And because it was so simple and so powerful, MCP didn't just stay some niche concept. Nope. It became the seed for an entire ecosystem that, and I'm not exaggerating, just exploded almost overnight.
And when I say explosive, I mean it. Just look at this timeline. In the span of just a few months, MCP went from being a project donated by Anthropic to a full-blown industry movement. It launched with major partners and a super bold vision for the future. The pace was just unbelievable. The real watershed moment was that MCP apps launch in January 2026. I mean, when enterprise giants like Salesforce, Asana, and Box all get on stage and say, yeah, we're building on this, it's not an experiment anymore, is it? That's the new standard. That one day really signaled that MCP was here for the long haul.
And the result was just crystal clear. The race to become the standard for how AIs talk to tools, well, it wasn't even a race. As AI agent engineering put it, MCP won so decisively it just became the de facto standard. Game over.
But, maybe the most important moment in this whole story wasn't actually about the technology at all. It was about governance. It was the decision to just give it away.
Back in December 2025, Anthropic made a really critical choice. They handed over complete control of MCP to the Agentic AI Foundation, which is part of the super respected Linux Foundation. And that is a huge deal. It ensured the protocol would be neutral public infrastructure, not just one company's proprietary toy.
And look, that one decision really did change everything. MCP went from being a project controlled by one company to public infrastructure, guided by the entire community. That move built an immense amount of trust and just slammed the accelerator on its adoption across the board.
So, with MCP firmly established as the standard language for tools, the community started looking ahead. They set their sights on a much, much grander future. They started asking what happens when it's not just one AI talking to a tool, but when AI agents start talking to each other.
And this was a massive shift in thinking. MCP started out as the plumbing, right? The pipes connecting a central AI to its tools. But the 2026 roadmap completely reimagined it as a nervous system, a system where specialized AI agents could talk to each other, delegate tasks, and work together to solve way more complex problems than any single AI could handle alone.
But of course, making that huge leap in capability from simple plumbing to a complex interconnected nervous system, well, that introduces a whole new class of risks and pretty serious vulnerabilities.
The security challenge here is just immense. I mean, look at this. Every single connection, from the AI model to the client to the server and the tools themselves, every single link in that chain is a potential backdoor, a place where things can go wrong or be attacked. Securing this whole thing is an incredibly complex job.
Okay. Now check this out. One of the most clever
and frankly scariest threats is something called tool poisoning. This is wild. An attacker doesn't even have to hack the tool itself. They just write a misleading description for it. This tricks the AI into thinking the tool does something totally harmless, when in reality, it's executing a malicious command behind the scenes.
And it's not just about malicious attacks, right? There's also a big strategic risk here. Good old-fashioned scope creep. The very ambition to become a nervous system could actually be its undoing. The danger is that by adding too many new features, MCP could become bloated and complex, losing that beautiful, elegant simplicity that was the key to its success in the first place.
So, okay, we've got this incredibly powerful, super complex, and yeah, kind of dangerous system. How in the world do you actually measure if an AI is any good at using it? How do you stress test these capabilities in a controlled, repeatable way?
Well, welcome to MCP Atlas. You can basically think of it as the AI Olympics for using tools. It's this massive, standardized test with over 1,000 real-world tasks that force an AI to find, chain together, and correctly use a bunch of different tools to get the right answer.
And here are the results. This is it, the leaderboard. This shows us the current state of the art, ranking the world's most advanced AI models on how well they navigated those 1,000 complex tasks. This is about as direct a comparison as we can get of their practical, tool-using intelligence.
And if we zoom in on the top contenders, you see a pretty clear hierarchy, with Claude Opus 4.5 out in the lead. But here's the kicker, right? Even the best model in the world is only getting it right about 62% of the time. That really shows you just how difficult these real-world tasks are and how much room for improvement there still is across the board.
And really, this brings us full circle to the core challenge we're facing. We are building this incredibly powerful, increasingly complex, and interconnected nervous system for artificial intelligence. And while the race for more capability is clearly well underway, the race for safety, for reliability, and for security is just as critical. The great challenge ahead is making sure those two finish lines get crossed at the same time.